Module 6.2. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 6.2. How can we visually summarize categorical data? In the previous note set, we looked at ways to summarize categorical variables. Here, we will consider other ways to numerically describe categorical variables, as well as visualize categorical variables. What are some other ways to numerically summarize a categorical variable? A proportion is the most common ways to summarize a categorical variable. Three common numerical summaries that involve proportions are prevalence, risk, and odds. A prevalence rate is a proportion that describes a population at a specific point in time. Prevalence rates are useful when performing a cross-sectional study. A risk is a proportion that describes the proportion of subjects that develop an outcome of interest, assuming that the date of collection began when the subjects were disease-free. Risks are reserved for prospective studies. Odds give us a way to compare the proportion with a certain outcome to the proportion without the outcome. The odds are the ratio of proportion with an outcome to the proportion without the outcome. Note that both prevalence rates and risk are proportions that are calculated the same way. The difference is in the interpretations, which depend on how the data is collected. This table summarizes different study designs we saw previously and the appropriate numerical studies. So notice whether the study is prospective, retrospective, or cross-sectional. Just as a reminder, prospective is when in the past, retrospective is the future, and cross-sectional is at a single point in time. Odds are appropriate for all three of these scenarios, whereas the risk is only appropriate for prospective studies and prevalence is appropriate for cross-sectional studies. What are some other ways to visually describe categorical variables? Bar graphs plot the frequencies or proportions of categorical variables. Recall, categorical variables can take numerical values or non-numerical values when the values represent names or labels. Examples include color, gender, and zip code. The y-axis usually denotes the frequency or percent, and the x-axis denotes the values the variable takes. The bars on the bar graph do not touch one another. So for example, we can summarize the categorical variable breed from the dog example using a bar chart. Looking at this plot, notice all of the bars are the same width. Also notice that each of the bars represents one of the possible breeds. The height of the bars corresponds to the frequency. Recall that in the 6.1 notes, we used a frequency table to summarize the categorical variable breed. The bar graph is just a visual representation of that frequency table. If you go back and look at the frequency table, Doberman had a count of 3. This is why the bar has a height of 3. There are many ways to create bar graphs. Most statistical softwares, including Excel, SAS, and R, will create bar charts. Bar graphs can be vertical or horizontal and should have the following properties. The x-axis should be labeled with the variable name. If creating a horizontal bar graph, the y-axis will have the variable name. The y-axis should be labeled with frequency or percentage. If creating a horizontal bar graph, the x-axis should be labeled with frequency or percentage. The bars should not touch, and the distance between each bar should be the same. Each bar should have the same width, and the graph should have a meaningful title. Oftentimes, when creating bar charts, each of the bars will be the same color, but some people prefer that each bar be a different color. A pie chart is a circular graph which denotes the percentage of times a case takes a certain value out of all possible values of the variable. The circle represents a whole. If you are missing data and still want to create a pie chart, you may need to use some generic categories such as other or missing. We could also summarize the dog breed variable with a pie chart. There are many ways to create pie charts. Most statistical software will create pie charts, including Excel, SAS, and R. So looking here at the pie chart, notice that each of the different breeds in our data set has a piece of the pie associated with it. The size of the pie is dependent on how many or the frequency of each of the categories. Pie charts should have the following properties. Often the different sectors of the pie chart are arranged clockwise in order of magnitude. Notice this pie chart does not have that property. If we wanted this pie chart to have that property, what we would need to do is we would start with the smallest slice, which would be Dalmatian, and then we would have the next smallest, which would be Doberman, and so far going in a clockwise manner. Pie charts should only be used for a small number of categories. A general rule of thumb would be 6 or fewer. Each slice should be clearly labeled with the category and corresponding percentage. So notice to finish this pie chart, not only would we want to label each of the slices with the category, but we would also want to look at the relative frequency table that we developed in Module 6.1 and place the corresponding percentages next to each of them. Also, the graph should have a meaningful title. It's important to not only know how to create the graphs, but be able to gain information from the plots. Summarizing the information in a meaningful way is the whole reason for creating the graphs. Looking at both the bar graph and the pie graph of the variable dog breed, notice that very quickly we can see that Pit Bull is the most common breed and Dalmatian is the least. This concludes the Module 6.2 video.